Hello and welcome back to Azure Terraformer. I've been working on my Terraform AT-ATs quite a lot, both the Azure DevOps edition and the GitHub Actions edition. And while I have been making announcements, I haven't really dedicated a lot of video content to these new changes that I made. Now, most of the changes are really not to the structural components of the AT-AT themselves, but to the samples that'll help you get off the ground running with these AT-ATs. And in case you're wondering what the heck an AT-AT is, it's a special type of module called Automate the Automation with Terraform. AT-AT. The W silent. These modules distill a common practice that I use when setting up Azure DevOps and GitHub projects and pipelines that automate Terraform. So basically, inside of an AT-AT module, you get a fully working Azure Terraform solution with full backend state, with full automation using either Azure DevOps pipelines or GitHub Actions. So I'm going to dig into that today. But before I get into that, I wanted to thank two new members. Yes, we have two new official Azure Terraformers. We have Andrew Webster and Stephen Carlson. Thank you guys so much. Not only is Stephen Carlson an official Azure Terraformer, he is also part of an elite squad of Azure Terraformer Code Ninjas, which have exclusive access to yours truly through our dojo in the Azure Terraformer Discord server. So Andrew Webster, Stephen Carlson, come on down. Join the Azure Terraform Discord, send me a DM, and I will put you in the appropriate role, and we can start collaborating more closely together. There's quite a few folks on the Azure Terraformer Discord asking lots of different questions, and even some of you wonderful Azure Terraformers out there are even answering some of the questions, so I don't have to. It's a wonderful thing. Besides, I don't know everything, so it's great that we have a lot more community engagement and folks that know stuff that I don't know answering these questions. So a big shout out to Rod Stewart, longtime audience member. Really appreciate what you do, Rod. But I just wanted to thank you, Andrew Webster and Stephen Carlson, for supporting the channel in this way. And Stephen Carlson, really look forward to working a lot closer with you on your Terraform projects through the Azure Terraformer Code Ninja Dojo. If you are interested in officially announcing to the world your status as an official Azure Terraformer, please click that join button down there and join the channel. It really helps out a lot. And what better way to announce to the world that you are an Azure Terraformer? There are other membership options, such as what Stephen Carlson signed up for, which is the Code Ninja Squad, which grants you exclusive access to my code reviews, where I can provide more hands-on mentorship in your software development journey. And then there's also my inner circle, which will get you access to me for 1 hour a month to talk about whatever you want to talk about. We could sit and play Mahjong if you wanted, or tic-tac-toe. Or we could talk about Terraform, cloud architecture, software development, you know, whatever. But I do know a lot about classical music, so if you want to pick my brain about that, that's always on the table. Anyways, that's it. Again, thank you to my new members, Andrew Webster and Stephen Carlson. Really appreciate your support. Without further ado, let's drop into code and let's look at the Terraform AT-AT GitHub edition. So here is the sample. This is probably the sample that you want to look at. It's the application environment. This is what's going to set up a typical Azure project that's going to provision an application to a resource group. And if you look at main, we see that we have the module declared here, and it's using a relative path. Now, when you go reference this module yourself, if you clone the repo and you want to use the sample locally like I am, then this is going to work fine for you. And it's going to pull whatever version you cloned off of the repo. However, if you want to reference the module over the internet through the registry, the relative path goes away and you're going to use something that looks like this. So the trick of converting the relative path in here is you go grab the version out in the repo. The source is going to be based on the namespace within the official Terraform registry. So my username out there, MarkTI, the module library, and then the provider make up essentially the namespace. Now, I I typically set up multi-module repos. And in order to reference one of the modules within my repo, you need to do a / and then the path to the module. So that's basically what we're going to change here. And then you need to leave the version there to pick the specific version. And then you can reference the module just like that. So that's how you reference the remote module if you don't want to go through the hassle of cloning the repo. I'll leave that in there just for giggles. So anyways, what is this sample actually doing? So I spent some time, setting up this sample to basically make this thing as turnkey as possible. So if we look at the variables, what are we taking here? And I'm just gonna diagram this here over on the side. So we're gonna take a name. We're gonna take a commit user, which is basically who you are on GitHub, because as you know, the Terraform AT-AT GitHub edition is gonna be checking in code to GitHub for you, right? So it needs to know who you are in order to do that. So these are the 3 input parameters. The name, this is, so if we go look at my TFR, actually my TFRs are going to be right here. And actually, I think my debug.sh script is going to be setting the name. The name is essentially going to be the repo, right? The commit user is who you are. And then the environment is actually a map with an environment name. In this case, I'm just setting up two environments, dev and prod. And you can go set up as many environments as you want, however you want them to be set up. And this is essentially the subscription ID for the dev subscription. So the GitHub AT-AT, just like the Azure DevOps AT-AT, a key feature of it is that it is multi-subscription. And so I can throw this on here, and I am going to provision a Terraform project that can deploy to 1 or more subscriptions. So we have that subscription isolation. Commit user, that's just going to be me. Who is that? Me, your GitHub user, who's going to get credit for all the commits that Terraform is going to do for you. This is a great way to hack GitHub, by the way. If you want to go get some quick commit history, using Terraform to automate GitHub, it's going to pump out a lot of commits for you. So I think I'm going to be setting up the live VWAN. So this is going to be the name of my repo. I'm basically setting up a GitHub repository where I can manage my virtual WAN. And I'm using the lib prefix for basically an environment that is going to actively manage resources in Azure. It's just one of those convention things. Okay, so these are the inputs to the sample. We'll call this the application environment sample. Okay. And it keeps capitalizing things, which is very troublesome. So this is where the boundary of the sample is right here. Okay, these are all inputs to this sample. So now inside the sample, what are we doing? So first of all, we are provisioning our multi-stage repo. So this is our Terraform. We'll call this our Terraform multi-stage repo module. That's kind of hard to read when you shout. Can't spell. Multi-stage repository. How about that? So that's kind of the big deal. Like this is the Terraform AT-AT. That's what this thing is. So I'm gonna highlight that in blue. Yeah, in honor of Azure. There we go. Bluish It's kind of purpley, but that's blue. That's blue. Now, this module needs some inputs, okay? And so if we look at what this module needs an application name. This module needs a name, which is really going to be for the repository. So the application name is the name of the unique identifier for the application or service that you're going to manage the infrastructure with and the release pipeline with. That could be distinct or should be somewhat related to the name of the repository, right? So if in this example, my name is probably going to be something like my core network or something like that, you know. So this is like my virtual WAN, right? It's going to be my core network, and my repo is going to be the actual live vWAN or something like that. You know, it might be live core network or something like that. But basically, this is the repository name. This is the application name as it manifests itself in the Terraform backend and all the things, right? So these are the inputs here. The next one, of course, we need our commit user, because the GitHub edition of the AT-AT is, of course, going to be doing the operations on GitHub. And then we have our environments, and our environments it's that map of Azure subscriptions, right? So that's what we're doing there. Okay. Now, basically, when you set up this application environment sample, you know, there's going to be some mapping going on, right? There's some direct mapping. We can see, you know, that we just carte blanche, we take the var name and the var commit user. So right off the bat, var name and var commit user are going directly into our GitHub AT-AT. Okay. That like nothing fancy going on here. Now, what is fancy is our environments are actually coming from a local environments. We'll call this extended environments. And we construct this local through some skullduggery. Okay. So if I scroll over here, we're inside the application environment sample. So we're going to be looking at how we prepare ourselves for the GitHub AT-AT. Okay. So I'm going to try and make some space for myself over here. So how do we get the extended environments? Well, first of all, the extended environments is using the variable environments, right? So it's not like this is a vacuum. Let me get rid of this. It's not like the environments just magically happen. We are taking some input from our variable, right? It's just we need more stuff than what the input variable has on it, right? And so we'll look into what that means. So what else needs to go into our environment? Well, if you see here, we have this module. So for each environment, we need to have a tenant ID, a client ID, and a service principal client secret. And then we also need a backend, excuse me. You can so basically each environment, each subscription needs, let's just call it an Azure credential. Okay. And then it needs a backend, right? So that's essentially what we're doing to construct this like local extended environments object inside this sample. Okay. So that's what's happening. Okay. So now the Azure credential, how do we get this Azure credential? Where this Azure credential is actually coming from this module called, well, we'll just call this the service principal module. Service principal module. Okay. And the service principal module, we actually have two of them. We have one for, shocker, we have one for dev, and then we have another for prod. And we're using the key, and a map of these to select the correct one. So basically these extended environments are gonna allow us to support both dev and prod. Okay. And then backends, is kind of the same thing. We've got, this local backends collection, which is we're using the key to grab the grab the back end. Let's just it's kind of the same fashion, right? We're going to have a dev backend for our dev subscription, and then we're going to have a prod backend for our prod subscription. And so basically this is how we're constructing the environments. So all you have to do to use this module is pass in the name of the environment, dev, the subscription ID for that environment, and do that for all the environments that you have. Dev, prod, each have a unique subscription ID, and this sample is going to construct an Azure credential and a backend for you on your behalf, right? So let's go look at how that happens. So if we go look at the service principal, that's under identity. What we're doing is we're actually constructing this module, and this is from my module library. It's actually my Azure AD, my Entra ID module library. And I just provision a simple service principal, right? And so that's how that's happening. So we'll call this the Azure AD service principal. This is Mark TI service principal module. And that's basically going to generate you an application. Inside there, what is it going to do? It's going to create an AAD application. It's going to create an AAD service principal. And then it's going to create an AAD service principal password. Okay. And the password is your client secret. Okay. So all three of these things combined, right, is going to produce a the credential that we use to access this service, this subscription. Now, the last thing that we need to do is we need to grant this service principal access to our Azure subscription, right? So we need a role assignment. Okay. That's going to connect this particular service principal to the specified subscription. So if it's the dev subscription, we're going to create a service principal that has access to the dev subscription. If it's the prod subscription, we're going to create a service principal that has access to the prod subscription. This keeps identity and access control isolated for each of the subscriptions, right? Which is a very good thing, kind of least privilege kind of thing going on here, right? So we don't have one service principal that has access to all of our subscriptions. We are creating a little bit of a security blast radius around the service principal itself, okay? Now, let's go look at, that's pretty much what we're doing with the service principal. And you can see here, we're for eaching over our environments for both the service principal module. We're passing in a generic name. So in Azure AD, I'm sorry, Entra ID, we're going to see an app registration and with this name, and it'll have a client secret there. So and then we'll have a role assignment in the respective subscription for what we set up over in in the diagram. So now the back end, okay, the back end, again, I'm using another one of my modules. This is a keep it simple stupid module. that basically sets a Terraform backend, a baseline Terraform backend, right? So this is a storage account with public internet access. Of course, you need to have the storage account keys and stuff in order to access it. So, or you need to have a role assignment that grants you access to the storage account, which our newly created Terraform service principals have access to. So this backend module, so we'll call this the MarkTI Azure RM Terraform backend module, is going to create a storage account. Well, it's going to create a resource group. It's going to create a storage account. It's going to create a container, a storage account container. It's very confusing because it uses the word container, which has been retrofitted, right? And we're going to create a different backend in a different subscription. And so, whoa, what happened to this line? There we go. So you can see what I'm doing here. I have two providers defined, and one is aliased as dev, and I'm getting the subscription ID from my input variable map, and I'm grabbing the dev subscription ID. So this provider block is now the dev subscription, and then this provider block is now the prod subscription. And then you can see that I am declaring two instances of my Terraform, my baseline Terraform backend, and I'm specifying the dev provider and the prod provider. And then to make things super simple, I'm creating a local map using dev and prod, and I'm just kind of I'm just jamming them in there at the right spot. So this is how I'm able to use locals to output that. Now, the backend config is an object that I output from my Terraform, my baseline Terraform backend, which conforms identically, very conveniently, to the object structure that my GitHub AT-AT takes in for the backend configuration. So this is one of those things where you can use objects in Terraform, complex objects as inputs and outputs to kind of streamline the interfaces between two codependent or interdependent modules, or modules that you want to loosely couple together, right? So it does streamline the integration of these modules. But again, I'm using big O notation of one. There is no nesting going on here. It's like I just have a single object that has three attributes, which is the resource group name, the storage account name, and the storage account container name. That's it. So we're not going too nuts with the complex objects. So that's pretty much the anatomy of this sample. There's a lot of stuff going on here, right? But it makes for a very simple turnkey experience, as we're going to see. So I've got all this stuff set up. You want to see me run it? Yeah? Smash like if you want to see me run it. Let's go. Okay, so we're about to go create 51 items. And these 51 items are going to span 3 Terraform providers: the GitHub Terraform provider, the Azure RM Terraform provider, the Azure AD Terraform provider. Folks, this is why Terraform is a superpower. Like literally, I can automate consistently across all 3 of these platforms in a completely seamless manner. It is truly amazing. So I'm going to go create 51 things. This is literally going to set up a single GitHub repo that has a fully working Terraform code base that all it does is provision a resource group. It's going to set up a service principal with a client secret in both my dev and prod subscriptions. It's going to set up an Azure RM backend using Azure Blob Storage in both my dev and my prod subscriptions. It's going to create the environments within GitHub Actions, and it's going to go tie all those things together. And when this is done, I'll be able to go to this repo on GitHub, this newly minted repo, and I'll be able to go run Terraform plan and Terraform apply in both my dev and my prod environments, and it'll actually provision that resource group out into that subscription and store it in a state file. I mean, it's literally turnkey. No setup on your part. So for a little bit of run good, smash like in 3, 2, 1. And hopefully we can get a clean Terraform apply here. Oh no. See, some of you didn't smash like. That must have been what it was. So let's see what happened. It looks like we just had like a little environment variable that failed. Maybe it was a transient error. For some extra run good, if you're one of those folks that didn't smash like and caused, you know, my Terraform apply to fail, please, for all the other viewers watching, please smash like on a count of 3, 2, 1. Just give us a little bit extra run good. Let's see if we can get it this time. There we go. See, if you only smashed like the first time, we would have been fine, you know. But just goes to show you, you know. All right, so we have a fully provisioned environment. I'm going to run apply again, and it's going to tell me there are no changes to my environment, which is going to be a wonderful thing. Because remember, Terraform is idempotent, which means I can keep running it over and over again, and as long as nothing changes, it's going to have nothing to do. There we go. 0 added, 0 changed, 0 destroyed, no changes. Your infrastructure matches the configuration. What a wonderful feeling. What a wonderful feeling. So now let's go out to GitHub. Oops. So now let's go out to GitHub and interrogate what we've created. So I'm out here on GitHub. Let me see if I can find my newly minted repo. I've got lots of repos going on here. Here it is, live virtual WAN. Updated 3 minutes ago. Magical. My awesome code base. Go log an issue. I need to fix the description, the default description of the GitHub repos that the GitHub AT-AT sets up. But you know what? AT-ATs are awesome. So it's not really a bug. It's more of a feature anyway. Anyways, so here we go. Let's go look at settings. Let's see what else we got here. We got environments, we got dev, and we got prod. All right. We can go look at this stuff. What do we have here? We have a subscription ID, 32 Charlie, tenant. We got a backend resource group name, ZTI, random strings. Okay. And all the good things. Okay. Let's go look at prod and see if it's different. So remember, the sub is 32 Charlie and the backend resource group is ZTI. Let's go look at prod and see if it's different. It should be different. So the subscription ID is not 32 Charlie. It's 20 Echo. And then the backend resource group name is 0 Whiskey 4, which is not ZTI. So as you can see, we have two environments that are provisioned to two different subscriptions, and we have a different resource group with a different storage account to hold Terraform state. The storage accounts largely have the same structure. You know, we got a Terraform TF state container name, but that really doesn't matter. Okay. The point is we have one code base with our awesome Terraform code in it here that is really, I mean, it's very awesome. It's going to produce this amazing resource group name. It's absolutely amazing. Very simple. You can go add whatever you want. You know, once you use the GitHub AT-AT, you know, just clone the repo and slam whatever you want into main, and you're off to the races. Because guess what? I can go over here. I can run plan. I'm going to run plan against my dev environment. Now, again, I haven't set up Git flow, so you know I'm using manual triggers to trigger plans and to trigger applies. This is something that I want to improve. But if you're building a lab environment, having the ability to manually trigger plan and apply is a pretty useful thing. If you're working on a team, you're probably going to want to set up git flow where a plan gets executed on pull requests to do kind of speculative, to do kind of a speculative Terraform plan on code changes that haven't been merged yet, that you're evaluating whether you want to merge them into main. And then a Terraform plan that gets executed on the merge into main or whatever long-lived branches that you want to maintain environments for. So let's go see if this thing, oh yeah, I'm sitting here yapping and the plan was successful. We want to go create this resource group in West US 3. We're looking good. So let's go run apply on dev. And while we're doing that, we're gonna run plan on prod. I'm being a good little Terraformer, and I'm running the plan before I run the apply. I have not fully set up a fully multi-stage pipeline in GitHub Actions. I'm still kind of new with GitHub Actions, but my Azure DevOps pipeline is a beautiful multi-stage pipeline that uses compiled plans. So definitely check that one out. My GitHub Actions, though, is a little bit, not quite there because I'm not using a true multi-stage pipeline. So we created a resource group. Now, because it is immutable, let me run apply again on dev, and we should see no changes. This should prove that the Terraform state is working. Let me also queue up a run of apply on prod, and we should see this happen. So we got Terraform apply on dev, Terraform apply on prod. While it's doing that, let me go look at my resource groups. So I've got my state ZTI here, 0 whiskey 4. One is in development, one is in prod. So my resource groups with the Terraform state files are in there. We go look at the containers, and I've got my TF state container, and I've got my obligatory application name and environment name as the backend key. Of course, this is another thing that that the GitHub AT-AT sets up automatically for you. And you can see that we do have a random in there, and we got a resource group that's set up in there. So I think we're in good shape. Our state file is looking in good order. Let me go look for the resource group that we provisioned. So let's go look at the dev environment. Let's get the resource group name. I can't remember. I guess if I search for RG-AZ-TF lab, it should come back with all the things. So I've got AZ-TF lab. Oh, there's actually a whole bunch of them. I guess I've been doing this a few too many times. So we're looking for Yankee to Mike. Yankee to Mike, Yankee to Mike. There it is. And that's our beautiful, glorious resource group. Okay. And over here, this is the only time I've done this to production. So we have our beautiful production resource group, Papa Delta Juliet. So let's go look at the apply on production, and we should be able to see Papa Delta Juliet as the resource group name. So there we go, prod Papa Delta Juliet. There we go, folks. I have set up a fully working end-to-end Azure Terraform project on GitHub Actions with a full CI/CD pipeline that provisions my Azure infrastructure using Terraform, using a GitHub Actions-based CI/CD pipeline. This is the power of the GitHub AT-AT. So, as I say, don't be a silly nerf herder. Hop into your AT-AT and blast the tedious setup that you do in GitHub and Azure DevOps to smithereens. I hope you enjoyed this. Go check out my Terraform AT-ATs, both the Azure DevOps edition and the GitHub edition. If you like this module, please smash that like button and consider subscribing to my channel. And also, if you want to work closer with me, consider channel membership, just like Andrew Webster and Stephen Carlson. Really appreciate the support. And don't forget, there are channel membership levels that get you more exclusive access to yours truly. So if you want to work with me more closely, definitely consider those options and sign up today. Again, that's it from me. Happy Azure Terraforming. It's even more fun when you do it from the comfort of your own cozy Terraform AT-AT. That's it for me. This is the Azure Terraformer, signing off.